Akash. I am pursuing MSc Cybersecurity, National College of Ireland. My research topic is trust-based cyber attack mitigation framework for routing over low power and low in. We are going to talk about cyber attack, importance of this research, existing approach and flaws in it, proposed methodology. So what is cyber attack? Mostly networks like peer-to-peer network rely on assumption of identity where each node represents an identity. Cyber attack happens when an insecure node is hijacked to claim multiple identities. And problem arises when a reputation system is tricked into thinking that an attacking computer has a disproportionately large influence. Similarly, an attacker with many identities can use them to act maliciously by either stealing information and disrupting communication. What are the existing methods for the mitigation and what are the flaws in that? Tampering with voting and reputation system. Usually, nodes use a voting system for deciding an honest node and SYBIL node. So as an example, an attacker may create enough malicious identities to uh, vote itself as an honest node and report and remove the legitimate nodes from the network. Alternatively, this malicious node can protect themselves from ever being removed as they are in the collusion. One of the approaches is resource testing. Consider that node wants to verify that none of its neighbors are SYBIL identities. It can assign each of its neighbor a different channel to broadcast some message on. It can then choose a channel randomly on which to listen. If the neighbor that was assigned the channel is legitimated, it should hear the message. The problem here is the nodes have to keep active listening, and this is a drawback in case of when you're having some limitations for the power consumption of the sensor node. Uh, the data aggregation was proposed as a result of a contrasting paper for research testing where sensor network reading are computed by query protocol in the network rather than returning the reading of each individual sensor. This is done for conservation of energy. SYBIL identities may be able to report incorrect sensor reading, therefore influencing the overall computation aggregation. A malicious user may be able to significantly alter the aggregate with enough identities. Suppose considering a network, the yellow nodes here are the nodes which are not affected by any malicious thing, and the nodes in the red color are SYBIL attack SYBIL nodes. If node A wants to send data to a node N, it is going through E, and if the SYBIL node is getting any broadcast message of A regarding choosing the optimal path, it can send and false information that node N is having the nearest location to itself with lesser hope. So what A will do is A will send the data to N through E, which is in SYBIL node. It can cause loss and degradation of the network. So what our approach is, uh, first, how to build the trust. The trust can be built using central certificate authority. When an end entity uses a certificate, a trust relation must be verified between the entity certificate and the root CA. So we are providing central certificate authority, and this trust relation between the root CA and the end entity certificate is verified by validating the contents of all the certificates in the certificate chain of the root CA. Next is response analysis verified by distance between hopes and comparing it with the routing table. So what we are doing is we are assuming that we already have the routing table. So that is stored with a secure protocol in a peer node. Okay, and what the response we will do is a node will send a broadcast. The honest node will send a broadcast message to the network. The responses will be, yeah, we will be able to analyze the distances, the hopes between every node. So we will compare this analysis result and the routing table, which is already secured by us, and any abnormality will be checked in that. So that can be considered as an SYBIL node. What we can do is applying, if it was issue in earlier paper, the earlier research, that there is problem with PKI for the power consumption power, computation power it uses. So we are implementing weightless communication technology for our RPL, So weightless is a long-range wireless protocol proposed and designed for the IoT. The low transmit power means that terminal can operate for the coin cell batteries. So it uses very less energy. Since a battery terminal device will nearly always spend a large proportion of time in an idle state, as it works like a group and only one of that will listen. As the is if there is anything for the group, then it alerts the whole group, and that time only it will consume energy. The power consumption is this mode becomes critical. Security in the weightless protocol which we are using is security is a critical factor usually in IoT cases. So system based on weightless technology benefits from leading edge data security provisions. AES 256-bit encryption and authentication of both the terminals and the network guarantees integrity, and temporary device identifiers offer anonymity for maximum security and privacy, as uh, data cannot be easily tampered as data is hidden. The proposed approach gives protection from cyber attack by multiple ways, as the central certificate and the voting and trusting of the nodes. Once that is done, the verification is done using a message broadcast. As the use of weightless protocol, only one node in the region is active to listen for the broadcast message and save power of multiple nodes. At the same time, weightless protocol gives an extra layer of security. It can be said that the simulation can give accurate results on the proposed research.